In this video, we will be dealing with the fundamentals of chemistry. Basically, we'll be taking atomic structure, bonding, and structures of molecules. But before we start, you might ask yourself, what is an atom? What is an atom? An atom is the smallest particle of an element that can take part in a chemical reaction. The smallest particle of an element that can take part in a chemical reaction. But contrary to Dalton's atomic theory, where he mentioned that atoms are indivisible, an atom can neither be created nor destroyed. But Rutherford, on his research on atom, discovered that an atom is made up of subatomic particles. We call them the proton, the electron, and the neutron. But what is a proton? What is a proton? A proton is a positively charged particle in the nucleus of an atom. It has a relative mass of 1 atomic mass unit. It has a relative mass of 1 atomic mass unit. Again, what is a proton number? Proton number? What is a proton number? In other words, we call the proton number atomic number. The proton number is the number of protons in 1 atom of an element. The number of protons in 1 atom of an element. Remember, the proton number is equal to the atomic number. The proton number here, the proton number is equal to the atomic number. What are neutrons? Of course, neutron is one of the subatomic particles. What are neutrons? Neutrons, these are uncharged particles. These are uncharged particles in the nucleus of an atom. And the neutron, they have the same relative mass as proton. They are uncharged particles in the nucleus of the atom. And they have a mass of 1 atomic mass unit. Then, what is a nuclear number? A nuclear number, or what we call the mass number. A nuclear number, or what we call the mass number. The nuclear number, when you look at the periodic table, you will see an element. You see the element there. You will see the nuclear number, and you will see the proton number. So, what is the nuclear number? What is the nuclear number? The nuclear number is the same as the mass number. We can say that the nuclear number or the mass number is the number of protons plus the number of neutrons in the atom. The number of protons plus the number of neutrons in the atom. Then, what are electrons? Electrons? What are electrons? Electrons are negatively charged particles found in orbitals outside the nucleus of an atom. You see the atom outside the orbitals of the atom. Electrons are there revolving in shells. So we say, at this level, we say electrons are negatively charged particles found in orbitals outside the nucleus of an atom. It has a negligible mass compared to that of the proton. The mass of the proton, the mass of electron is about, the mass of an electron is about 1 over 1,837 atomic mass units. That is the mass of the proton, the mass of the electron. So we say again that electrons are negatively charged particles that are found in orbitals outside the nucleus of an atom, and they have a mass of 1 over 1837 atomic mass units. It takes us to isotopes. We hear of isotopes every day. What are isotopes? What are isotopes? Isotopes, these are atoms of the same element having the same proton number or atomic number, but different mass numbers or nuclear numbers due to the different number of neutrons in them. We say isotopes, these are atoms of the same element, having the same proton number or atomic number, but different mass number or nuclear number as a result of the difference in the number of neutrons. So here, if you want to an isotope should be an isotope should be something that has same atoms. We say atoms. We say they are atoms of the same element. They are atoms of the same element, have same proton or atomic number, have same proton number, different mass number, have different mass number due to what? Due to different number of neutrons, have different neutrons. Neutron number. You have different number. An example of this could be something like we can say chlorine 35. We can say chlorine 35, chlorine 35, chlorine 35, and chlorine 37. We could still use an example of this to be carbon 40, carbon 12, and carbon 14. Carbon 12 and carbon 14. So precisely we are saying that an isotope, isotopes, these are atoms. These are atoms of the same element, having the same proton number. We have this, having the same proton number, but different mass number, different mass number. As a result of what? As a result of the different, because they have this one, they have different number of neutrons. These have different number of neutrons. So that is the simple definition for isotopes. But again, what are radioactive isotopes? Radioactive isotopes, or what we call them, radioisotopes. Radioisotopes, or what we call radioactive isotopes. Radioisotopes or radioactive isotopes, these are unstable atoms which break down, emitting radiation in the form of alpha, beta, and gamma rays. When they break down, they are very, very unstable. And when they break down, they emit radiation. These emit radiation in different rays. They could be alpha, they could be beta, they could be gamma. And some of these rays are very useful in medicine today. For instance, in radiotherapy, in modern healthcare units, some rays are used to treat cancer by killing the cancer cells. Some of these rays are used to kill the cancer cells in cancer patients. An example of this is cobalt 60. Cobalt 60 that's used. Cobalt 60, which is used as whose rays are used to kill cancer cells in cancer patients. On the other hand, non-radioactive isotopes are stable atoms. These ones are very stable atoms. So we can conclude the atomic structure and the atomic structure, or the atom and its subatomic particles, to be that the proton, we can say proton, the proton number, or what we call the atomic number, the proton number, or what we call the atomic number, the atomic number or the proton number is equal to what? The proton number, or what we call the atomic number, is equal to the number of electrons. Number of electrons in one atom. In one atom. Then we can say the number of neutrons. We can find the number of neutrons by using a number of neutrons equals to what? Will be equal to nuclear number nuclear number, or what we call the mass number, minus number of protons, minus proton number. So we can, if you use that at this level, you can easily have it. We can say we can summarizingly say that the proton number or the atomic number is equal to the number of electrons in one atom. Then the number of neutrons, we can get the number of neutrons by subtracting the number of protons from the nuclear number. So number of neutrons will be equal to the nuclear number or the mass number minus the proton number. When we do that, we can easily have our subatomic particles in order. Then, if I might ask, why are, I can ask again, why are atoms neutral? Why are atoms neutral? Why are atoms neutral? Or why do atoms have no charge? Why are atoms neutral? Why are atoms neutral? Atoms are neutral because they have no charge. Atoms are neutral because the number of protons are equal to the number of electrons. Why are atoms neutral? I can say atoms are neutral because the number of protons are equal to the number of electrons, and as a result of it, they cancel each other. Protons are positively charged, electrons are negatively charged. So if the number of electrons are equal to the number of protons, then they can cancel out each other, and the molecule will be, the atom will be neutral. For instance, I want to use sodium. Sodium has 11 protons, 11 protons, and 11 electrons. 11 protons and 11 electrons. And we know that protons are positively charged. Protons are positively charged, so we have 11 plus. Electrons are negatively charged, so we have 11 minus. So what will be the total? We add all this, will be 0. Therefore, the molecule will be what? The molecule will be a neutral molecule, sodium atom. The same way it goes to magnesium. It goes to magnesium. If I have magnesium as magnesium has 12 protons. Magnesium has 12 protons. We have 12 protons, and we have 11 electrons. We have it has 12 protons and 12 electrons. Again, protons are positively charged. Again, electrons are negatively charged. So if we add up all this, our total molecule will be what? It will be a neutral molecule. So that's why we said, why are atoms neutral? The atoms are neutral because the number of protons and the number of electrons are equal and they cancel out each other. It drives me to another one which I can say. Another question which I can say. Why do atoms have positive charge? Or why do atoms become cations? Why do atoms have a positive charge? Why do atoms have positive charge? Or cation? Why do they form cation? In this case, the simple answer for this is that atoms will form cations because they have more protons than electrons. They have more protons than electrons. When they have more protons than electrons, protons are positively charged, electrons are negatively charged. To cancel out each other will not work. There will definitely be a difference, and that difference in it will give the charge on the atom that makes it a cation. So in that case, let me, for example, sodium again. I want to use sodium as our example. If I have sodium, the sodium atom, let's say it has 11 proton, and it has only 10 electrons. And you know that 11 protons means 11 positive charges, and the 10 electrons mean 10 negative charges. If we add all this, there will be a positive here. There will be a positive, a difference of a positive. So in that case, what happens? Sodium will be what? It will be a sodium ion. There is a positive charge there. So we now say atoms have positive charges, or atoms form cation because they are more protons than electrons. They have more protons than electrons. I can go again to clarify my learners on this other aspect of it. I can give this question again. Why do atoms have negative charge? Or why are atoms anions? Why do atoms have negative charge? Why do atoms have negative charge? Why do atoms have negative charge? Now, if they have negative charge, the difference is clear. It's because they have more electrons than proton. In that case, I want to still illustrate it using the same example we have been using here. Here, I can say, let me use chlorine. Chlorine atom, yeah. Excuse me, please. Okay, chlorine. Chlorine atom has 17 protons, sorry. And and 18 electrons. This is equals to 17 plus charges, and this is equals to 18 negative charges. If we sum up all this, we will have a difference of a negative. And the difference of a negative gives what? Give chlorine a negative charge. It means that there are more electrons. And that one gives chlorine a negative charge, which is an anion. So you can carry out many more examples why atoms are positive, why atoms have positive charge or they form cations, why atoms have a negative charge or they form anions, or why atoms are neutral. These are all the simple reasons. Okay. Again, we have to go into how atoms are arranged. How atoms are arranged. In that case, we have to arrangement of electrons. It drives us to the second part of it, arrangement of electrons in arrangement of electrons in an atom. You know that an atom is made up of this, an atom. The atom is made of the nucleus, and this is the nucleus. The nucleus of the atom is there, where in the atom we have the proton and the neutron. We have the proton there. The protons are positively charged. The neutron, they have no charge. So the protons are positively charged. They are the protons. The nucleus is made up of the proton. And this and the neutron. The proton and the neutron. Because the neutrons they have no charge. The protons are pronounced. The protons are pronounced. In that case, the protons they have a positive charge. That's why the nucleus is positive, because the neutron they have no charge. So in that case, the nucleus is positively charged because it is full of all the protons. The neutrons, they have no charge. So outside the nucleus, we have orbitals. And these orbitals are arranged in shells. These are orbitals. This is the first shell. These are shells. These are all the shells. This is the second shell. This is the third shell. This is the third shell. So this is the first shell, n equals to 1. The second shell, which is n equals to 2. And the third shell, which is n equals to 3. Remember, these are electrons. Electrons are revolving around the shells. These are electrons that are here. Electrons are moving around the shell. We have electrons Electrons that are moving around the shell, electrons are moving around the shells. All the shells, they are all of electrons. Electrons moving around the shells. So remember, these electrons moving around the shells. But the first shell, according to the rule, the first shell, which is n equals to 1, that is closest to the nucleus, n equals to 1, is supposed to have how many number of electrons? 2 electrons. The second shell, after the first one, is supposed to have, according to the rule, is supposed to have 8 electrons. The third shell is supposed to have, the third shell and the rest is supposed to have also 8 electrons. Then the outermost shell, we don't know the number of electrons that are there. We don't know the number of electrons that are there. And if this one, if it is like this, if we have 2, 8, 8, this is a noble gas. This is a noble gas. So now we want to represent this in this order. We have carbon. Carbon has 11 electrons. I mean 6 electrons. 6 electrons. If we arrange this, it will be the carbon. If we arrange this in the order of electron, how electrons they appear, it will be the first shell will contain 2 electrons. So the first shell, n equals to 2, will contain 2 electrons. So n equals to the first shell, n equals to 1. N equals to 1 will contain 2 electrons. So the second shell, n equals to 2, n equals to 2 will contain how many electrons? They are supposed to be n equals to 2. N equals to 2 was supposed to contain 8 electrons, but because carbon has only 6 electrons, if 2 electrons are already taken, then the second shell of carbon will contain only 4 electrons. And if we are to arrange the electrons in order, it will be 2, 4. It will be 2, 4. If we are to arrange another electron, another element, let me say sodium. If we arrange sodium of 11 electrons, sodium has 11 electrons. The first shell will be equal to 2. The second shell, 11 minus 2, what will be left will be 8. The second shell would be 9. So it will be, the second will be 8, already 10. So from 11 electrons, we have already consumed 10 electrons. So the last electron will be 1. It therefore means that sodium has 1 electron in the outermost shell, and carbon has 4 electrons in the outermost shell. The number of electrons in the outermost shell will identify the element, will identify the group where the element belongs, and that drives us to the second part of it, which is the periodic table. The periodic table. That drives us to the second part of it, which is the periodic table. From our explanation, the periodic table. Arrangement of atoms and the periodic table. From the periodic table, you will notice that in the periodic table, elements are arranged in order of increasing proton number. They are arranged in order of increasing proton number. As you are going across the group, you are adding one one proton. As you go down the group, you add 8 electrons. I mean 8 protons. So across the group, I mean, because the periodic table is arranged into groups and periods. Groups and period. And as you go across the group, as you go, I mean, as you go down the group, the columns. These are the groups, are the columns, and the periods are the rows. So the periodic table is arranged into columns, and rows, and the columns are the groups, and the rows are the periods. So as you move across the period, there is an increase in the proton number. As you go down the group, there's an increase in the as you go across the period, there's an increase in the proton number by 1. As you go down the group, there is an increase in the proton number by 8. So we say elements in the periodic table are arranged in order of increasing proton number. We are considering the first 20 elements of the periodic table. For the first 20 elements of the periodic table, we say elements in the same group have the same number of electrons. Elements in the same group have the same number of electrons. For instance, we can say, group 1. Group 1 group 1 elements will have how many electrons in the outermost shell? They will have 1 electron. 1 electron outermost shell. Group 2 elements. Group 2 elements, they will have 2 electrons in the outermost shell. Group 3 elements, they will have, group 3 elements will have 3 electrons in the outermost shell. In that order, group 4 elements will have 4 electrons in the outermost shell. Group 5 elements will have 5 electrons in the outermost shell. Group 6 elements will have 6 electrons in the outermost shell. Group 7 elements, which are the halogens, will have 7 electrons in the outermost shell. And the last group, which is group 0 or group 8, which are the noble gases or inert gases, will have 8 electrons in the outermost shell. That is how the periodic table is arranged. Once more, the periodic table is arranged. This is an arrangement of elements in order of groups and the periods. As you move from left to right across the rows, those are the periods. As you move from top to bottom, those are the columns, and these are the periods. So the periodic table is arranged into groups and periods. The periods are the rows and the groups are the columns. And they are arranged from group 1 to the noble gases. In between are the D block elements or the transition metals. Now, it leads us, when we have ionic compounds from between all these, how can we determine their compounds? It leads us to how to determine the formulae of ionic compounds. How to determine the formula of ionic compounds? How can we determine the formula of ionic compounds? How to determine the formula of ionic compounds? We have different methods of determining the formula of ionic compounds. Method number one. Method one, determine formula of ionic compounds. How we can determine formula of ionic compounds? We have the method number one. Method one is by swapping the charge on the ion. Method one. Method one. For instance, we want to use sodium carbonate. Sodium carbonate is our example. Sodium carbonate. How do I know sodium carbonate is an ionic compound? How can I determine the formula of sodium carbonate? Method one, by swapping. And in this order, what do we do? The first thing is, step number one, we write the ions involved. We have sodium, and we have the polyatomic ion, which is the carbonate, sodium carbonate. Okay, step number two, identify the ions. Which are the ions? The ions here are, let me identify the ions to be base. These are the ions, and these are the ions. Okay, we need to swap. I said method number one is by swapping the ions. If we swap, it comes here. This one comes here. And this one comes here. And what will be here? Here we have 2 will come here. Ignore the sign, please. 2 will come here, and 1 will come here. Ignore the signs. Just use the figures, ignore the sign. So the negative 2 will come here, and the positive 1 will come here. And now our structure will be what? Our formula will be, the formula of this compound will be what? The formula of this compound will be sodium. There are 2 sodium, we put a 2. And the carbonate, there's only 1 carbonate, so it remains. That is the formula. If we go further again, if we go further again to do for magnesium hydroxide. Magnesium hydroxide, magnesium hydroxide. We need now to write what? We need to write the ions. Magnesium is M2 plus. Mg2 plus. Hydroxide is OH minus. Okay, we need to swap them. The simple way to swap them is this way that we're talking of. this one, and this one. And what happens? They comes here, and they comes here. And this will be what? This will be 1, and this will be what? And this will be 2. Now, what becomes of the nature of the formula of our ionic compound? It will be magnesium is 1, then hydroxide, there are 2 of them, OH. You don't need to write the charge on them again. You don't need to write the charge again, please. So there are 2 OH, so we put a 2 here. That is the formula. It goes again with aluminum oxide. It goes again with aluminum oxide. Aluminum oxide Let's draw the structure of our compound. Write the formula. We now have aluminum is Al3 plus, and oxide is oxygen. Oxygen is 2 minus. Oxygen is 2 minus. So in this case, we need to see what we can do in trying to swap them. So we circle them. And then we have to swap this. And we have to swap this. In that case, here we have 2. And here we will have but 3. So in writing our formula, it is Al, there are 2, and there is O, 3. That is how you can do that. Method number 2 in the same process. Method 2. Method number 2, you can use how to balance the charges. Again, we go now to sodium carbonate. Sodium carbonate, let's go back to sodium carbonate. Sodium carbonate. Sodium carbonate. Okay. Step number 1. Step number 1, you need to write the ions. Write the ions. We have sodium and the carbonate. Okay. We want to balance the ions. Let's see how we can balance these ions. The ions here, we have a positive charge. We have this. We need to balance the ions so that they can cancel out. So here we have only one positive, but there are 2 negative here. So we need another 1 positive to cancel this one. So what do we do again? We need to add another 1 positive there. So in that case, we will have sodium again. We will have another sodium again, but we will not add anything here. So this will be minus. So in this case, we now have what? In this case, we have balanced them. Let's see how we can balance it so that it can cancel out. Here we have 2 plus. We have here, there are 2 of the, here we have 2 of the ions. So we have a ratio of 2 is 2. We have only 1 ion here. There's only one ion here, so it's just a ratio of 1:1 or 2:1. Now there are two pluses here, and there's only two negative. So these two pluses can cancel this one. And let's add up. When we add up our charges, you'll see that here there are two ions. When we add up the ions, there are two ions here that have made up 2 plus. There's only one ion here that has made up 2 minus. So in that case, we are going to write our formula based on the ratio here. So now our ratio will be the ratio of our compound will be sodium to then carbonate. That is how you can write it. Let's go another example. The last example will be for the last example here will be aluminum oxide. Aluminum oxide, which we did the other time. Aluminum oxide. Aluminum oxide. Step number 1, write the ions involved. Step number 1, write the ions involved. I write the ions. Oxide is oxygen. Step number 1, write the ions. Then step number 2, identify the charges. Identify the charges by circling them. We identify the charge. We identify the charge. Okay. Step number 3, balance the charges. How can we balance this one? This cannot balance this one. This cannot balance this one. Let's add this one. Let's add another sodium. Let's add another aluminum oxide and see if it can go. An aluminum ion, sorry. Let's add another ion to see if it can go. And let's add, if we add this, and let's add this one and see if it can go too. Now we have added, now there are 6. There are 6 plus. Now there are only 4 plus. The third step is, what do we do here? We cannot add here. Let's add but here. Let's add another ion. We will not add here, but let's add here. 2 minus plus 2 minus plus 2 minus. There are 6 minuses. 3 plus plus 3 plus. There are 6 plus. So this one can balance. So now we can now do it very well now. Let's balance it. We have here only 2 of the aluminum ion. The ratio is, we have here 3 of the oxygen ion. The ratio is 2:3. And now let's write aluminum. Let's write our compound. Our ionic compound will now be aluminum, 2 of them, oxygen, 3 of them. That is how you can do it. Once more, given a compound like aluminum oxide, the first thing you do is you need to write the ions involved. Aluminum oxide ions involved. The ion for the metal and the ion for the non-metal. Secondly, can we cancel out the charges? They cannot cancel. So the only thing is, we need to make the charges to be the same so that we can cancel them out. Let's add another aluminum ion. We now add another aluminum ion. That is step number 2. Here, we come again. When we add another aluminum ion, we add another oxide ion. So it is 2 minus. Now we now have 6 plus and only 4 minuses. Now, in order to balance the charges, we cannot add this one. We must add another one here to make it 6 negative. So we add another oxide again. So we now add them. When we add, now we have 6 minuses we can now have 6 minuses here. I mean, 6 plus here and the 6 minuses here. The 6 plus can now cancel the 6 minus, and now it is the charges are okay now. Now the last stage will be how many in which ratio are the ions? How many ions how many of the aluminum ion did we add? We added 1 and 2, so we have 2. How many of the oxide ion did we add? We added 1, 2, 3 to balance the charge. We have 3 oxide ion. So the ratio is 2:3. And now let's write our formula. Our formula will be aluminum 2 and the oxygen 3. That is how you can do to balance the charges. It drives us to the bonding. It drives us to bonding. We have to go to bonding now. It now drives us to bonding. And we are starting the first bond with, the first bond will be with, the first bond here will be with metallic bond. The first bond will be a metallic bond. Now, what is a metallic bond? What is a metallic bond? I